am Yvonne and I'm from the United States. Today I'll be presenting my research on a literature review about machine learning's application to the drug discovery process for Alzheimer's disease. First, Alzheimer's disease, as we may all know, is the most prevalent neurodegenerative disease worldwide. But disease-modifying treatments are still lacking. And traditional drug discovery methods, however, are sometimes time-consuming and not as cost-effective. So for a lot of researchers, in order to find new treatment, ways to treat Alzheimer's disease, researchers started to shift their gear toward machine learning-aided drug discovery process. And these new technologies have promoted a transformative breakthrough in drug discovery because of their capability in doing large data set analysis, multifaceted data processing, and also exploration of intricate biological mechanisms. So today I'll be covering three main areas. First is data curation for ML-aided drug discovery process. And second, it will be machine learning methods for drug screening. And thirdly, I will be sharing some known applications of machine learning on Alzheimer's disease research. So first is about the common databases being used for drug discovery process. And because ML-aided drug discovery is almost completely computer-based in its initial stage, so identifying the correct database for the raw data would be really essential. And indeed, there exists a lot of common databases that researchers use, and they all cover different aspects of research, and researchers are allowed to choose based on their interest and their project. So first type of databases will be gene expression databases. That includes GEO and TCGA. And then there's also gene function database, including KGG and BioSig. And then there is biomolecular databases, which includes PubChem and Zinc. And then we have medical chemistry database, including DrugBank and Chembel. And also lastly, there's compound decoy database, DUD. And in addition to having the raw and the information about the chemicals or a specific gene expressions, researchers also use multiple chemical descriptors to further characterize the chemicals that are involved in the research process. So most descriptors are divided into 5 dimensions. The first one being the 0th dimension, which is the simplest ways to describe a chemical. For example, we have the number of atoms and number of bonds of a certain type, and so and so. And then there's the first one-dimensional descriptors, usually represented as fingerprints or binary digits 1 and 0. And some of the examples would be carbon atoms, number of primary carbon atoms, and so on. And then there is two-dimensional descriptors that describes the property that can be calculated from two-dimensional representations of molecules. And there's two main types of that, being the structural topology index and also topochemical index. And there's also three-dimensional descriptors, which relate to the 3D representation of the molecule and includes the conformation of the molecular structure. And some of the examples will be polar and nonpolar surface area, shape index, principal moment of inertia, and electrostatic potential. And lastly, there's 4D descriptors that provides additional information by introducing a 4th dimension, which includes molecular dynamics trajectories, binding kinetic parameters, energy landscape, and time-dependent quantum, and so on. And secondly, as researchers develop more machine learning and deep learning based algorithms, other researchers are also trying to implement them into their own research in their drug discovery process. So in the past few years, multiple machine learning algorithms were involved in the process of drug discovery for Alzheimer's. And the first one being support vector machine, which is a supervised learning model to solve complex classification, regression, and outlier detection problems. It works by representing input data as feature vectors and plot them in a space with the same dimensionality. And SVM models is often used to predict organic molecules and compounds properties. And secondly, a random forest algorithm is also commonly used. It comprises of a considerable amount of slightly varied decision trees and proposes a classification for input by considering the most prevalent output among all its decision trees. And random forest is used to improve predictions and then select naturally trained molecular descriptors for um, enzymes, hormones, receptors, and so on. And it is also used to classify the ligand protein binding affinity to improve the scoring function performances and to predict multiple inhibitions of multiple proteins that are involved in the Alzheimer's disease progression process. And also there is the multi-layer perceptron, which is a supplement of a feed-forward neural network. It consists of three types of layers: the input layer, output layer, and also the hidden layer in between. And one example of a research using MLP will be the study of Yavas et al. That shows a greater classification success seen using multi-layer perceptron, since the secondary structure of protein offers a greater advantage in determining protein function and drug design. And there is now I'll be talking about some deep learning based models. First one is deep neural network, or DNN. It is architecture traces the outcomes in a mathematical model that can be presented in a neither nonlinear or linear relationship. And for example, what Pat research drew inspiration from Kaggle's outcome and conducted enhanced investigations on multitask DNNs. The results for multitask DNNs have showcased remarkable performance in learning general features and sharing parameters among proteins and drug candidates. And the second type of deep learning network would be CNN, or convolutional neural network. It is a subclass of DNN and is ordinarily utilized for various tasks in computer vision and image processing due to its ability to effectively capture spatial hierarchies of features and data. And researchers have employed CNN models to predict affinity and protein ligand interactions mostly. And CNN algorithms has also demonstrated ability to forecast binding affinities, potentially enhancing scoring functions. And lastly, for the deep learning networks, there is the autoencoder network. So it is designed to learn efficient data representations, typically by encoding the input into a lower dimensional latent space, and then reconstructing the input from this latent representation. An autoencoder is trained to minimize the error of reconstruction and dimensionality reduction, and to learn the data from a generative models, which is also a reason why it is largely used by researchers. And autoencoders is used to map a genome-wide protein interaction network onto a low-dimensional representations. Okay, so those are some of the machine learning algorithms that are currently being used in machine learning aided drug discovery process. And there are also multiple, like I said before, there's a lot of studying focusing on ML approach to find drug candidates for Alzheimer's. And I pick out a couple to talk about here. The first is Bao et al. It is they use a rule-based ML approach with classification trees applied to design novel dual target ACHE and BACE inhibitors. And those two are proteins and DNA sequences that are believed to have caused or accelerate the progression of Alzheimer's. And next, there is Xie et al. That conducted sequential docking to identify compounds capable of inhibiting both, also the two genomes that are involved in AD progression. And a research by Stefano et al. Have identified two novel CDK5 inhibitors for CDK5 through an ML-based machine learning framework, further showing that the implementation of ML in drug discovery process for Alzheimer's have shown some success to a certain extent. And lastly, there's Kumar et al., who utilized ligand-based virtual screening to search for MTDLs inhibiting also the two proteins and genomes involved in the development of Alzheimer's. So with all these past research, data curation methods, and also machine learning frameworks being used, it's really obvious that over the past few years, researchers have made a lot of advancements on utilizing new technologies and new algorithms into finding cures and finding ways to diagnose Alzheimer's. And the utilization of machine learning and visual screening for drug discovery is indeed anticipated to expand significantly as the science community recognize its transformative potential in the field. And also the joint efforts of computer science and medical chemistry are poised to streamline the drug discovery process, making it more efficient and cost effective. So I feel like we cannot anticipate that in the near future, researchers will be able to use machine learning to minimize the time and um, cost for drug discovery process, and which can accelerate the process of finding drug candidates for Alzheimer's that will be able to cure millions of people worldwide. And that will be it for my presentation. Thank you for listening.
Thank you, Yvonne, for that very detailed but concise literature review. It sounds like we have much to look forward to in terms of applying machine learning to medical chemistry and Alzheimer's disease. So that's really exciting.